Hello.
Hello, guys.
Ngài là xuất tình em.
Yeah, how is you?
Ang long yung
Good, good.
sinunod
How are you?
I'm good, thanks for asking, brother.
Right. How is everyone? Hello, everyone.
Hello, hello. Are you able to mute others so we can... Hey, Tino,
Yes.
are you able to mute the other participants so we can
Alright.
concentrate?
All right. Let me, if I can. All right. So, guys, let's just be cooperative so that we can have maybe one meeting, because muting everyone can take some time. Because I would like you guys to also participate with me here.
So no pity alpha. Abanye abanjengami.
Hello, guys. Let's try to meet ourselves.
Tino,
Bonita, please mute yourself. You are very loud.
all
All
right,
right.
cool.
Thank you.
I think all is good now, sure.
Okay. So I think we can start now. Okay. Before we proceed, I'd like to hear from you guys. Did you face any challenges from our previous meeting regarding the installation part? Regarding the installation of the JDL and the Java Development Kit, did you face any challenge? All right, so I think we can proceed today's work. What are we going to cover? Perfect. So, guys, I assume you successfully did it well. All right, so today we're going to cover Unit 1. We started late, and I assume we're going also to finish late. So basically we started at 7:30, so around 8:30 or before 8:30 we'll be done. All right, so today we are going to do I'm sure today is going to be the first and the last day regarding to do with theory. The theory part. So starting from next week onwards, we'll be doing the practicals, the coding. So you are not going to see any more slides from me. It will be we are going to deal with the JGrasp and also your study guide here and there. Yes, you can see maybe Word document with few theory, but it's going to be rare. It's going to be rare since this module is all about practice, right? So today we're going to do the Unit 1, an introduction to algorithms and programming. So first of all, before we start, what is computer programming? That's the first question that everyone is asking right now. What is computer programming? So please don't be scared. Don't worry. We're going to break this into basics so that everyone can understand the same way we did the installation part, and almost everyone is saying you did very well. You did not face any challenge regarding the installation part. So that's what we are going to do regarding this module. So what is programming? Right? So many people believe that computers are incredibly intelligent, and I assume you guys, that's the same that's what we all think to say. Someone is saying I faced challenges. All right. Where exactly did you face the challenge? Where exactly did you face the challenge? So I think we are going to discuss after this. I think the last 15 minutes of this module of this session, we're going to revisit again the process. Or I suggest you follow the previous recording that we did step by step. I'm sure you can win without any fail. It's very simple, guys. It's clear and straightforward. You need to download the JDK, you install it, you run it, then you need to install it on the environmental path, right? So my first suggestion on this problem, where can I find the recording? Did you guys receive the recording that we did last time that we have done? No. All right. So I think you can just request in your group from James you sent to you. You can request the introductory recording or the introductory session that we did on Thursday last week. He can send to you. I promise you guys, he'll send to you. All right. So programming. Everyone assumes that a computer can do everything for us. And that's the reality, right? That's the reality. A computer can do everything for us. You just need to press the button, everything. But that's a great misconception, guys. A computer does not do everything for us. Have you ever heard about the concept whereby they say garbage in, garbage out? Right? That's the concept of computers. Computers only, actually, they literally do nothing, right? Computers literally do nothing. They don't do anything because at the end of the day, they are not like us human beings, whereby you can breathe, we do all those things, we have 5 senses. They depend on us. Whatever we feed them, that's what they'll give us. All right? So it's now our duty. That's the reason you are learning this module. To say, I want to be a programmer. Right? Tino, would this be recording you are referring to? I think I'll check it later. I'll check it later on so that I can confirm, I can positively confirm. I think for now, let's try to focus on this session. Then we'll come back to you, Obi. Please allow us to exclude just maybe for 45 minutes from now. Then, because at the end of the day, I want you guys to all start from on same page. You have your JDK, your IDLE environment. You can also program. You can also do the practice. So we'll come back a little bit later, maybe after 45 minutes from now. We can help you to install it on your computer, right? All right. So I was saying a computer, it operates under the principle of garbage in, garbage out. Whatever you feed it, that's what exactly what it will give you as a what? As a programmer. Or so who is going to give the instructions to the computer? The person who's going to give a computer instruction is a person who's called a programmer, right? So a computer is similar to a toaster, is similar to a machine, is similar to an elevator, right? So all those things, they have what we call instructions. To say, press this button, it will start to do something. A bank application, log in, put in details, enter, right? It now give what? Enter wrong details. It will give you an error message. So it operates under our instructions as a what? As human beings. So we write those instructions to say, okay, whenever I want you to do this task, I'm going to pre-write a code. I'm going to pre-write instructions. So those instructions are what we basically call as a program, as a code, right? So you see, a computer is basically useless at the end of the day. It literally depends on us. So what we are going to do throughout this module, we are going to write different kind of programs, different kind of instructions, right? That's what we are going to learn. So when we write those programs, when we write those instructions, we are trying to solve a problem, right?
Here we go.
Here we have a problem, like when we have something like a washing machine, right? We want to solve a certain problem. What is that problem now at hand? The problem now is we have a bulk of laundry. You don't have time. You are doing something else. Hence, someone, an innovative person, okay, let me create a program. When you plug it to the power, it reads. When you switch it on, when you put instruction to say put on this part, rinse and so forth, you know, a washing machine, it listens exactly what you instruct it to do. So it does it perfectly. So those are programs that were predefined to say, when we do this, do this. When you do this, do this. Right? So that's the basic understanding of programming. So we write instructions on behalf, right? So a simple definition of computer programming is computer programming involves writing a series of precise instructions in a language that a computer can interpret to execute a specific task. So we have a problem. You write predefined instructions. So those instructions at the end of the day should be precise, right? To say you have a macro, you put it on maybe on 2 minutes. It should be precise to say on 2 minutes it will switch off. It doesn't go to 10 minutes, doesn't go to 15 minutes. Precisely on 2 minutes, it will stop. So you predefine those instructions. It should be precise, right? So when you write those instructions, you follow what we call a procedure. You don't start from maybe from 30 minutes when you press 2 minutes, right? It has a starting point. It has an output. It gives you an output. You insert something, and at the end of the day, it should give you a what? An output, a product, right? So how now do you structure those instructions? That's when you hear the word algorithm, right? You hear now the word algorithm, whereby let me scroll down. So I'll go back and forth using also your study module, and also my my notes. So algorithms now comes into play. How do you write those instructions? So we have a microwave at hand. We want to solve a problem. It's a problem. There is my cup of coffee. It's what is now cold. I want to heat it, right? So you insert to say, okay, I want it to maybe to heat it in 2 minutes. So you press the button 2, then enter. So those instructions they follow in steps. They are in order, right? So now as a programmer, you want to design your microwave on paper. You need to write those to say, okay, after this, I'm going to do this. After this, I'm going to do this. After this, I'm going to do this. Then at the end of the day, press enter. Right? Then it runs. After it runs, it gives you the what? The output. Hence, on algorithms, each and every algorithm, those precise instructions, they should follow an order. They should have steps to say, after this, I'm going to do this. So those instructions, that's what we call a program or a code that a computer can understand at the end of the day. Because a computer, basically, a computer does not understand this language to say, enter A, B, C, or so forth. You are going to see that as we move on. It understands what we call low-level language, right? That's why now we have installed the JDK, right? So going back a little bit, we have algorithms at hand to a step by step to say, okay, we want to create a code. We want to solve a problem, a certain problem. How are you going to write that? It should follow steps and steps. So basically, what is an algorithm in programming? An algorithm is a step-by-step set of instructions. What are those instructions? Those are the codes, a program. Whenever you want to solve something, you write it, you give a computer a series of instructions, right? Those instructions should be precise, right? So now, a step by step after this and this, that's what we call an algorithm, designed to solve a specific problem or perform a particular task. It is a well-defined procedure that takes inputs, right? That's the first thing. Process it accordingly to the instructions given and gives output. So from this definition, you can see that in algorithms, what we call an algorithm, it has some certain features. It has some certain characteristics, right? It should have an input. It should process it and give you the output. Going back to the example of a macro, right? What are the input? You need to insert a cup of coffee. You need also to put the amount of time to say, I want it to run to hit within 2 minutes. Then you need to press the button enter. Those are the what are the input. Then the process now, it runs for what? For 2 minutes. After it runs for 2 minutes, the output, it stops. And you can take off your hot cup of coffee. Those are the processes and the input or the features of an algorithm. So the same applies to say you have your phone, you have a calculator. A calculator is a basic computer, right? So that or let me say a calculator. The programs were already written and it was embedded in those Microsoft and so forth, in those chips within the computer. So whenever you insert an algorithm, you want to solve a problem, maybe to say 1 + 1, what's the output? Your input now, you say you press 1 + 1, you hit enter, then it processes. But now the advantage of computer now is, like we said, it literally does nothing. But when you give it something, it does it faster. That's the difference now with human beings. So computer, whenever you give it instructions, it performs it very, very, very faster. So those algorithms, step by step, you need to know them in mind to say, okay, you don't say plus, then you say 1 = 2, right? Whenever you punch it in your calculator, you don't start to press plus, then you punch it 1, then you punch 1 and say =2. You follow a certain step to say 1, then you press the plus, then you say 1, then you press the equal sign. So it's an algorithm. It's an algorithm on itself, step by step. of instructions. Right? So the algorithm now, you write it down. How do you present your algorithm? Algorithms can be presented in the form of a flowchart. So these are the what are some of the characteristics of a what of an algorithm. An algorithm should be complete. An algorithm must provide a solution. The first feature of an algorithm should be complete. It should give you the result. You can't say 1 + 1, then you leave it like that. You need to put it equal sign. Or you can't say 1, 1 without putting the addition part. Right? The algorithm must provide a solution to the problem it is designed for. If an algorithm does not solve the problem correctly, it is impossible. So the main purpose of an algorithm, if you maybe you want to install something, you have bought an appliance, right? Maybe a microwave. How do you install it? So it's basically a step-by-step procedure. How do you going to operate it? So algorithms, you are installing a software. They give you a set of instructions, step by step. After this, you have bought your microwave. How do you plug it? You do this and this and this. So that's the purpose of an algorithm. It should be complete to the extent that it's now working. It's now solving the problem with what? At hand. Right? And ambiguous. That's another what? Another feature. Each step in the algorithm must be clear and well-defined, leaving no room for multiple interpretation. So when you give someone your code, you should present an algorithm at the end of the day. But now, as programmers, you end up knowing everything. You don't need an algorithm. Say, okay, from this step, you go to this, you go to this, and this, and this. Right? But when you give a third person who doesn't know anything about Java or anything about programming, it should be clear, well-defined, leaving no room for multiple interpretations. Say, okay, this person, what exactly was it or she trying to solve here? It should be complete. Right? Another feature, deterministic. Given the same input, the algorithm must always produce the same output, ensuring consistency. Right? That's another what? Another feature of an algorithm. Whenever, right, we have an algorithm, I'm going back to the example of a microwave. That program, someone came and wants a cup of coffee. You should do the same process that you have done before whenever you were serving yourself. Right? It should give you the same output. It should be uniform. It should be consistent. And it should start and it should end. That's the last feature. Finally, the algorithm must terminate after a certain number of steps. It cannot run indefinitely. It should give you the what? The result. So this is an important part of programming. Every code that we are going to write, going forward from this, when we are going to learn this module, it should have an algorithm. It should, okay, we are going to create a class. We are going to create a code. Hence, class, you define your class, it does this and this, and at the end of the day, it should end. Right? It should be complete. Otherwise, it will give you errors. Hence, you need to debug, you need to do a lot of things. Right? That's another what? Another feature. So, define programming. You need to know what is programming. Write a set of instructions, and those instructions should be in a certain pattern. It should follow step by step to say, after this, you do this, and this, and that program should execute and give you the what? The output. You are solving a problem and it should give you what? An output. An elevator. A program of an elevator. You request an elevator, that's a program. The input, you press the button, you get the elevator, you get in the elevator, you press the button, you request the floor that you want to go. Then at the end of the day, it should terminate. If it doesn't terminate, you continue to go and go. Hence, you'll be confused where I'm going to first floor. Hence, it should what? It should end. Right? So, an algorithm, I have a picture here. I hope you guys can clearly see an algorithm, a feature, an example of an algorithm to find sum of two numbers. This is an algorithm. How do you present it? You can present it in form of a flowchart, in the form of a pseudocode, but most common one is a pseudocode or a what? A flowchart. An algorithm, you start, then you read A, B, C is equal to A plus B, print or display C, stop. So we are going to see this as we progress. What are the variables and so forth? But for now, this is the structure. It ends, it starts, it ends. This is the process. Flowchart. So you can present any problem that you may think of. You may be what problem can you think you want to do something in your house? How are you going to what to do that? You start, at the end of the day, you stop. Right? Flowchart, it has some certain features, it has some certain patterns that can be followed, and arrows, and also the decision that you can make, yes or no, proceed, yes. So this is typically what an example of a flowchart. Then here we have a program, the actual program. Now you are coding, you are implementing what you write on the algorithm here on the actual instruction that the computer can understand, to say, okay, whenever you enter maybe these variables, you give it numbers, to say system input, print line, enter the value of A, then you through the keyboard you enter, right? You enter the value of B, then it now calculates and give you the what? The output. So this is basically what an example of your program. That's what we are going to learn throughout this module. Right? So how now do we write those instructions? That's the question. We want to solve a problem. How now do we write those instructions? That's when the concept of programming languages come into play. But specifically for this module, we're going to only to learn Java programming language. So like I said earlier on, computers only understand what we call binary code or machine language or assembly language, right? So programming languages serve as the medium through which programmers communicate with computers. These languages have syntax, right? These languages have semantics that define the rules for writing those what? Those instructions, those code. Because the purpose of a code, the purpose of a program, you want to solve a what? Problem. Programmers use various programming languages, paradigms, such as procedurals, object-oriented, or functional programming to structure their code and solve different types of problems efficiently. So we have types of programming languages. So a programming language, like I said here, it serves as a what? As a medium through which programmers communicate with computers. So we have different types of what? Of programming language. We have what we call machine language, assembly language. Then we have higher level languages. So on machine language here, whenever we write code, you can open your JGrasp here. Whenever you write a code, right? Whenever you write a code, you can come here, file, then you say new, then you choose what? You choose Java. Whenever we write a code, I think I have a code here. Let me copy here so that I can explain it in detail. Paste it here. All right. Save. All right. So here I have a code. Public class, hello world, public static, void mentioning, blah, 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 right? Right? So this is my what? My code here. I'm trying to solve a problem. What's the problem? The problem is I want this to display hello world. I just want it to display hello world for me. That's the problem. I want it to write something or to write my name. I want this program, this laptop to write my name. I don't want to write it on Word or anywhere else. So here it has been displayed hello world. So I want to break it down for you guys. The concept of programming language, as you see this computer or whatever gadget, phone that you are using, that you are holding, or laptop that you are holding, that you are using right now, this laptop or computers or machine or whatever, they don't understand this language that you can see here. The definition of computer programming or this code, public class, hello world. This is what we call higher level language. But computers, they only understand what we call machine language, which is binary code, zeros and ones. So what does it mean? It means everything that you are going to write here, it's going to be converted into zeros and ones, right? Whether you write a long code, maybe with 10 pages, a long one, a computer does not understand all those languages that we know as human beings. It converts each and every word or each and every letter that you're going to write in alphabetical into zeros and into ones and zeros, right? Binary code is extremely difficult for humans to understand. So for us to write all these things, I think long back when they invented computers, they were using this. I remember when I got to college, we learned another module to do with binary language and assembly language. And I was wondering, why are we learning all this? But now I appreciate it more. Why? Because a laptop doesn't understand all this. It only understands this. So the reason now they come up with Python, with Java, with PHP and so forth, it's because it's difficult to understand all this and also to write these zeros and ones here. We only understand English as human beings. So a computer, the main purpose of the Java development kit is now to compile, to translate everything that we are going to write here, this code here, into zeros and ones. But we don't see it. It is happening on the behind using the Java development kit, right? So the reason they invented high-level language is to overcome this issue of what? Of zeros and ones, which is being understood by what? By computers only. So now we are now using Java as a programming language. We are now using Python as a programming language. But everything is being translated, compiling to zeros and ones, because a computer only understands those two things, ones and zeros. So it compiles, it translates it and understands it and sends you back to the language that us as human beings understand only. Right? So for this module, we're going to discuss about Java. This was developed in 1991 by a company called Sun Microsoft. Then later on, it was bought by Oracle. Now it is under what? Now it is under Oracle. Oracle is now owning this what? This Java. So now Java, how it works, it is now using the Java development kit is now being translated into Java bytecode, right? Bytecode, where it's getting the concept bytecode, binary what? Binary language, binary code, binary ones and zeros, right? So that's how it works. So it is executed by Java virtual machine that is installed on your computer. How do you install Java virtual machine? When you install the Java development kit, you also install the Java virtual machine. That's why it is impossible for you to run any Java application without configuring the JDK. You need to have the JDK. I hope I am clear on that part. Are we still together, guys? Are we still together?
Yeah.
Yes, we are.
Chino,
Alright,
we are still
so-
here.
Okay, so let me continue. We are left with 30 minutes before we are done for today. All right, so to solve this concept of zeros and ones, and also later on, they say, okay, let us develop it's like an evolution. We started with machine language. That's what people used to learn long back. And they introduced assembly language to say, let us have move, add, sub to do, instead of using the binary, requiring an assembly translator into machine code. So they developed this assembly language, but it was also difficult to understand, and it was only useful for certain types of operating systems. As long as you have another operating system, it will not work. But to counter all those problems, they developed high-level language, which is now Python, Java. You see, with Java, you say public class print hello world. This is very understandable. You can read it. It's easy for us human beings. So I want to give you assignment, guys, for you to go and practice. And don't be surprised. They usually ask your lecturers at Mancosa, what are the advantages and what are the five advantages and 5 disadvantages of high level languages in programming? High level language language programming. Yeah. High level what you call programming language. What are the benefits? I want you to just maybe research, maybe in point format, and what are the disadvantages. I want you guys on our next meeting, I want us to discuss this. So I want you guys to present, maybe for the first 3 minutes or 5 minutes, to present what are the advantages and disadvantages. The reason why I'm asking it is because I found it somewhere in past exam papers. So it's very important for you to understand. So some of the popular programming languages are Python, Java, C++, SQL, JavaScript, and so forth. PHP are some of the high-level language. So I want you to research what are the benefits and the disadvantages of this programming language, and also what are the features of an algorithm? Why do we use an algorithm? Just go and research, because I've discussed it. I want to test you guys. Are we on same page? So going forward, guys, what we're going to do is I hope we have installed this part. This is our next, what we have done this part, installing the Java. Then today we just want to get familiarized with what, with this part, with this screen, the JGrasp IDE. So this IDE, the Integrated Development Kit, is just a platform, guys, where we write our programs. So I also want you guys to go and, on top of that assignment, to discuss the benefits of IDE, 5 benefits of IDE. What are the 5 benefits of IDE? Discuss the 5 benefits of IDE, right? So basically, IDE, an IDE is a program that is designed to help programmers and developers build software. So now we want to learn how to build software. The purpose of the software is to solve a problem, right? Hence, we are giving a computer. Everything that you see, guys, now in this world of AI, it has computer. It can be smaller, it can be smaller, right? Like a phone, a microphone, a camera, a sense, and so forth. It's there to solve a problem. A bank application, the problem, you don't need to go to the bank, you find queues and so forth. Hence, they say, let us develop a bank application, right? You give it instructions, then those instructions, like I say, garbage in, garbage out, you give it good information, it gives you the what? Same good information, but it is being executed very efficient at fast rate. So an IDE typically contains a code editor, compiler, debugger, and other utilities, all integrated in a single package, and presents all this via a graphic interface. So this is the graphic interface. With an IDE, you can do multiple tasks with the click of a single button. There are many different IDE for creating Java programs, but for the most popular are Eclipse, NetBeans, IntelliJ IDE. For academic purpose, the preferred IDE is JGrasp. That's why we say, let us install JGrasp. Mancosa prefer using JGrasp. So there are so many Eclipse, NetBeans. Yes, you can use it, but for the sake of exams and also learning, this is what it's free, simple, and straightforward. So you can click it, and it will give you something like this. You come here on files, then you say new. You want to create a what? A Java program. You say Java, right? This is where you are going to what? To create your what? Your program. So basically, Java, how it operates is creating a what? Our first, this is going to be our next unit. So just a what we are going to see moving on. Your first program, you scroll Java, it's there on your what? On your module. So Java, how it operates is Java operates using classes, right? I'm going to create some few slides on it. What are classes, right? Because every program that we are going to see, it has got a class. It uses the concept of modularity. So everything is going to be bind into a class. So it's like you have a house, right? You are building a house. You put a door, right? So the entry part of a program to say, okay, I want my program to start running. For your program to run, this is the door. the door part, the entry part, the main method. We call it main method. So it's default. Each and every program or code or instructions. Let me say instructions, because programming is all about writing precise instructions. So those precise instructions, instead of saying, I'm going to write precise instructions, we simply say, I'm going to write a what? A code. I'm going to write a what? A program. So please, guys, don't be confused. You are going to write precise instructions. What are you going to solve? I want it to display my name, to say, hello, Tino. Right? I want it to calculate maybe 2 numbers. I want it to display, maybe I want to purchase something online. Right? So those precise instructions, that's what we call computer programming. How do we write them? We write them using step by step, because we want to solve something, but we are going to write it on an interface. This is the interface. Before we deploy a systems, we need to write it somewhere before the deployment in the actual environment. Before maybe you upload it on Google Store, you need to write it somewhere. Where do you write it? Before you upload it on Play Store, right? You write it on an IDE so that you can debug it if there are errors. So that's why I gave you the assignment to say, what are the benefits of integrated development IDE in programming? Just go and research those benefits. So on our next meeting, we're going to discuss how Java operates. When you say public class, you'll be surprised. Why are we writing public class? Where is it coming from? Right? I think most of you guys, you have now a lot of questions. Yes, we're going to write instructions, but why are we using public class hello world? Because the first thing is, let me a little bit go back with you guys to your modules, on some of your notes. High-level language or high-level language that we are using now, like Java, it has got what we call, I think I have it here on my definition. I said these languages have syntax, right? When we say syntax, we are simply saying the rules that define that language. Think of English. It has got noun, it has got verbs, it has got punctuation, question marks, and so forth. The same applies to Java programming language. There are some names that you say, okay, how can you write a noun? You use a capital letter, right? How can you put a punctuation? Why do we put a full stop? Why would you put a semicolon? Those are some of the what are syntax. It has got its own rules, right? Like here, public class import Java .util.scan. These are the rules that define that language. You go to isiZulu, it has got its rules, its naming convention to say, if you write a name of a seat with a small caps, you write a name of a person with a small letter, it doesn't sound well, right? The same applies to Java. It's like we are now learning a native language, a new language on itself. So basically what we're going to do is we're going to learn a new language, guys, and we are going to enjoy it. That's all I can say for now. It's a new language. We need to break it down. It has got syntax. It has got its rules. When you learn English at school, how do you write a sentence? How do you write a paragraph? The rules that guides English language. The same applies to what? To Java. That's programming language. So the main challenge that I can say most students suffer is they ignore the part that we are learning a new language. At the same time, we are trying to solve real life problems that we face using a new language. So just take it simple, guys. You are learning, maybe you have migrated to Europe, to Germany. You are learning what? German language. You are learning Java. But the good part now with learning Java is it's for your own benefit. Employability, right? Not just for attaining a degree. Yes, some they can do it for attaining degrees, but employability part of it, once you pursue this course, is something else, guys. I can promise you that it's something in the industry that we are now living. Most softwares are being developed using what? Using Java programming language. Most softwares that are being developed using what? Using Java programming language. So we are going to learn that on our next meeting, creating our first programming language. That's what we are going to focus on, and where we are coming from. Basically, we are learning Java to write all those precise instructions, step by step, solving a certain problem. I think for now we can end here for today. Any questions before we close? Any questions?
Off topic.
Yes.
I know you said you'd attend to that text I sent in the chat, but if you can, check if that is the recording you are talking about for everyone else, including me, who haven't yet installed that because I had issues installing it.
I'm with OBTUT, I wasn't available when you guys went through the installing.
All right. Let me see. Yes, I'm sure I can use that. All right. I'm sure it's one of my previous on introduction to Java. This one is similar to one that we have done today. It's similar to one that we have done today, but you can also go back to. I'm sure it has got the
It was
installation
posted 2
part.
weeks ago.
2 weeks ago. Let me share.
Yeah.
Yes, it has got the installation part. I can confirm that. I think on 33 minutes. Yes, on 32 minutes going forward. Yes, I was also doing the installation part. Yes, you can also listen to that. I can positively confirm. Someone is asking here, do all programming languages, I assume, have same rules or they differ from language to language? Yes, they differ from language to language, but once you master one programming language, it will be easier now to switch to another programming language. Yes, they have different rules. They have different rules. I'm sure the easiest of all is Python. The easiest of all is Python because Python is pure English language. You can say 8, 5 plus 5, 8, 5, and 5 to give you 10. So the easiest of all it's Python. But for Mancosa, we're going to do Java. That's what they want, but they have different They have different rules. So we're going to learn a new language. That will be my my conclusion for today. Any questions, guys? Any question? All right. I think we
And
can
then-
end here. Yes. Yes.
Sorry,
something
sorry,
to-
Tino. And then the one that you have posted previously, if you can, please do share it so we can refer to it also.
All right. May you please kindly request in your group, James will send to you.
All right,
Because
will do.
Me, I don't have access to this. Actually, James does have the access.
Okay, thank you.
All right. You're welcome. Good night, everyone. Let's meet again next week, same time, 7 p.m.
Thank you,
Thank
Jane.
you.
Thank you.
Cheers, James.
You're
Cheers,
welcome.
Tino.
Cheers,
Good
Tino.
night, everyone.
Good
Bye.
night.
Bye.